Welcome back after the break, and let's continue looking at the plateau having an influence on South Africa's climate. Now, we have already established just before the break that this is basically a cross-section from the west coast to the east coast of Southern Africa. And you can see what is a plateau. Just to define a plateau, it's this flat area in the interior. This over here. Now, this area over here, as soon as you move down to the coastline, is known as the Escarpment. It's a bunch of mountain ranges that exist in Southern Africa. Now, my question to you, just before we went on the break, is when we increase with altitude, the temperature drops with 1 degree Celsius for every 100 meters. But how come places in the interior experience higher temperatures than the coastal areas if we're much higher in altitude? Now, Gr12, the simple reason for it is what we discussed a couple of minutes ago. Places like Port Nolloth and Durban, what type of temperatures do they experience? Maritime climate. What does the maritime climate do? It's been influenced by the ocean currents. It moderates the temperature. Now, places over the interior, like Johannesburg over here, what type of climate do they experience? Continental climate. So they experience nothing can moderate the temperatures over here, and that's the reason we experience warmer conditions over the interior than at the coastal regions. And that's the reason why the altitude factor doesn't play a huge role over the interior of Southern Africa. Now let's continue with the next slide. We've already established plateau. It's the flat area found in higher altitude. Altitude is height above sea level, and it's always in meters. So like I've mentioned, for every single 100 meters we increase with altitude, the temperature drops with 1 degree Celsius. Now, the steep escarpment, I showed you what the escarpment is. Let's just quickly back. It's these areas over here. What it does, it prevents moist air, especially from the east coast, reaching the interior because it needs to move very high. Now, what happens when this moist air rises? Because it's so high, it cools, condenses clouds and it rain. So before this moist air can reach us and let the formation of rain take place, it rains before it actually reaches us. Now, as I mentioned over here, the temperature decreases with altitude. Therefore, the plateau might experience lower temperatures at lower altitudes. Now, in our previous lessons, we discussed cyclones. We looked at the mid-latitude cyclone and we looked at the tropical cyclone. And what we've established is the term cyclone is a low-pressure system. What do we know about low-pressure systems? It's rising air. And so we can say low-pressure systems equals cyclones. But today, I want to concentrate, and what we're going to look at is anticyclones. Now, anticyclones is high-pressure systems. Now, Gr12s, if a low-pressure system, a cyclone, is rising air, well, there's a high-pressure system, sinking air. Now, South Africa is dominated by 3 high-pressure cells, and this is vitally important. The reason why we are dominated by 3 high-pressure systems is because we are situated on a 30-degree latitude line. Let me just quickly refresh your memory, and then I will come back to this diagram. If you can remember global air circulation of air, first of all, the equator, the 30 degree, 60, 90. Now, where is South Africa situated? we are situated right over here on the 30-degree latitude line. Now we've learned in the past episodes that a low pressure belt exists at the equatorial regions because of warm conditions. And what happens over here? A high pressure belt exists on the 30-degree latitude. And that, Gr12s, is where we are situated. And the three anticyclones that we experience is the South Atlantic high pressure, the Kalahari high pressure system, and the South Indian high pressure system. Now, before I'm going to continue, let's just quickly look at high pressure systems. Now, a high pressure system is sinking air. That's the first thing that we need to remember. It's sinking air. Another characteristics of a high pressure system. In the southern hemisphere, it's an anti-clockwise circulation of air. And in the northern hemisphere, it is a clockwise circulation of air. Now keep in mind, it's sinking air, and in the southern hemisphere, it's an anti-clockwise circulation of air. Now, as you can see, the South Indian, this thing keeps on jumping. Let's just get it right. This is the South Atlantic high pressure. Please, Gr12s, bear in mind that when we refer to them as high pressure systems or anticyclones. Then we have the Kalahari high pressure, and last but not least, the South Indian. Now, the names are kind of self-explanatory, because if you look where this high pressure system is found, it's found over the Atlantic Ocean. And if we look where South Africa is, south of the equator, the Kalahari high pressure over the interior, this area over here, we experience the Kalahari. And obviously then we have the South Indian high pressure over the Indian Ocean. Please, Gr12s, don't get mixed up between ocean currents and oceans. Okay. Now, let's quickly look in detail into these three anticyclones or high pressure systems. We've mentioned them: South Atlantic, Kalahari High, South Indian. And these are anticyclones. Now, like I've mentioned, the characteristics of them: sinking air, anti-clockwise circulation in the southern hemisphere, there's descending air, warming at roughly at 1 degree for every 100 meters. So as the air sinks, because South Africa is not situated where the polar regions are, is not as cold, we are closer to the equator. As the air sinks, it warms up. Now, it creates fair, sunny and warm conditions. Now, if you look in comparison to the northern hemisphere, where the 30-degree latitude north of the equator is, you will find very arid regions. Not much rainfall because of its high pressure systems. It's extremely difficult for rainfall to form where high pressure systems are present. Because what's happening with the air? It's sinking. In order for it to rain, what does air need to do? It needs to rise. And eventually when it rises, it cools, condenses clouds and the possibility of rain. So especially the best possible example I can give you that we're going to discuss in detail. If you look at fair, sunny and warm conditions and you live in the interior of Southern Africa, you will notice during winter times we experience this conditions almost every day during winter season. And that is the simple reason why is because of the high pressure system over us, because it's sinking air. There's no air rising. That means that can't lead to any cloud formation taking place. And then obviously we're going to look in detail the movement of this pressure belts, this pressure systems, the South Atlantic, Kalahari high pressure and the South Indian high pressure during summer and winter months and how it influences our climate. Now let's quickly look at the first one, the South Atlantic high. So you can call it the South Atlantic high pressure or the South Atlantic anti-cyclone. Now where is it situated? Over the South Atlantic Ocean, basically just off the coast of Namibia. Right? What does it create? It creates onshore southwestern winds in the South Atlantic west coast. Now let me quickly explain that to you before we're going to continue. Now, if this is South Africa, and what's important, you need to know the characteristics of your high pressure systems. So let's draw the South Atlantic high pressure belt, high pressure cell. Now what do we know is the air circulation in a high pressure system, anti-clockwise in the southern hemisphere. Now, because of the anti-clockwise circulation, this area over here is going to experiencing onshore flow. And this area over there is going to experience, whoops, just erase that. Offshore flow. It's kind of self-explanatory if you look at it. What happens over here? Because of the circulation, the movement of this air is onshore, coming onto land. And because of the circulation, the air moves offshore flow. So what does it create? Let's go quickly back to the characteristics. It creates onshore southwestern winds to the South Atlantic west coast. Why? Because of the anti-clockwise circulation of the high pressure system in the southern hemisphere. Now, very importantly, it's stable air. When we look at mid-latitude cyclones and tropical cyclones, rising air is unstable air. Sinking air is stable air. Now, it creates no rain because we can't have any cloud formation taking place with sinking air. In order for rain to form, what needs to happen? It needs to be warm, air needs to rise, it needs to cool, it needs to condense clouds, and it leads to the possibility of rain. And the simple reason for it is because it's descending air. And what makes it less of a chance of rain taking place on the western coast of southern Africa is because of that cold Benguela current. Now, we've already established, if we look at where the South Atlantic high pressure system is, let's just quickly use a purple color over here. What ocean currents do we find over here? Sorry, this is a bit too dark. Let's use a lighter color. Now we got a cold Benguela ocean current, and we have already established, when we look at the factors influencing South Africa's climate, that it creates cool, dry conditions. So the chances for rain for this western coastline are very scarce. even though there's onshore flow bringing in the air over the coastline, but because of the cold Benguela current, the chances for the formation of rain will be minimal. Let's just go back with the South Atlantic. Okay, very importantly, and I'm going to discuss this with you now, when we look at mid-latitude cyclones, it's the cold front that provides the Western Cape with winter rainfall. Now, the reason the mid-latitude cyclone can reach us is because this system, the South Atlantic high anticyclone, migrates towards the north. And during the summer, it migrates to the south. I will continue after the break to explain this to you in detail.